Hello there, this is Rodel. Welcome to my channel. What is scientific notation? What is it for? How do we use it? In today's video, I will share to you how to write numbers using the scientific notation. So please stay tuned. I'll be right back.
What is a scientific notation? Scientific notation is simply a convenient way of writing very large and very small numbers. It was developed for the purpose of easy recording, reading, and understanding of number data. Scientific notation has two parts. First is the coefficient part, which consists of a number greater than 1 but less than 10, and the second part, which is the exponent part, which is powers of 10. Example, 5.123 times 10 to the power of 6. 5.123 is what we call the coefficient part, while 10 to the power of 6 is what we call the exponent part. Now, how do we rewrite a number using the scientific notation? Example, the sun's diameter is estimated to be around 1,392,000,000 meters. Write this measurement in the scientific notation. The answer would be 1.392 times 10 to the power of 9 meters. Now, how did we get 1.392 times 10 to the power of 9? It is obtained simply by factoring using powers of 10. 1,392,000,000 by factoring can also be written as 1.392 times 1 billion, or 1.392
times 10 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 times 10,
or simply 1.392 times 10 to the power of 9 written in the scientific notation. Now, in writing an ordinary number in the scientific notation, there are 4 simple steps that we can follow. Are you ready? Let's start. First is locate the decimal point of the given number. In our example, our given is 1,392,000,000. Now, if the given number is a whole number and has no decimal point indicated, place a decimal point beside the last digit at the right. So in this case, the last digit at the right is 0, and we will place a decimal point beside it. Right there. Okay, step 2, move the decimal point to the right of the first non-zero digit from the left. Now, this is a bit confusing, so let me explain this very slowly. Our given is 1,392,000,000. So, looking at the left side, the first non-zero digit from the left is 1. So, we will move our decimal point beside 1. Right there. Okay. Now, it is very important to be reminded that we must count the number of times we moved our decimal point. Why? Because this will serve as the exponent of our scientific notation. Shall we start moving now? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we moved our decimal point 9 times. Step 3, drop the non-significant digits. Now, as I said earlier, the purpose of writing numbers in the scientific notation is for easy recording. So it is convenient that we drop non-significant digits. So we now have our new number, 1.392. The last step, step 4, multiply this new number by 10 to the power of n. So 1.392, we write times 10 to the power of n. Now, since our n is 9, because we moved our decimal point 9 times, we can replace our n by 9. So this is now your answer written in the scientific notation. Final answer would be 1.392 times 10 to the power of 9 meters. Now, if there's a unit indicated, do not forget to write the unit. Now, it is also important to know about the sign that we are going to use in the exponent of our scientific notation. If the decimal point is moved to the left, our n would be positive. If the decimal point is moved to the right, our n would be negative. Now, in our example, since we moved our decimal point to the left, we moved it to the left, therefore, our n is positive. So that is why you have positive 9 as your exponent. Now let us have another example. The average diameter of a human blood cell is found to be 0.000085 meter. Write this in the scientific notation. Solution. So remember the steps? Okay, we will apply the steps. First, you write the given 0.0000085. Locate the decimal point. Locate the first non-zero digit from the left. And locate where you are going to move your decimal point. So to the right of the first non-zero digit from the left. Okay, let us move our decimal point now. So let us count 1, 2, 3, 4, 5, and 6. Next, drop the non-significant digits. Then you multiply it by 10 to the power of n. Okay, now why do we have 10 to the power of negative 6? Or why is our n negative 6? First, because we moved our decimal point 6 times. And we moved our decimal point to the right. So, as the rule said, if we moved our decimal point to the right, our exponent would be negative. So that is why you have 8.5 times 10 to the power of negative 6. And your final answer would be 8.5 times 10 to the power of negative 6 meter. So do not forget the unit if it is indicated in the problem. So it's becoming easier now, isn't it? So let us have a few more examples so that you can master the skill. Example 3. The number of bacteria found in a certain laboratory is about 40,150,000. Write this number in the scientific notation. Remember the steps. So first, you write the given. Locate the decimal point. Now, if there are no decimal point indicated and the given is a whole number, so you simply place a decimal point at the right of the last digit at the right. Then, locate the first non-zero digit from the left, because beside it is where we are going to move our decimal point. Okay, shall we start? Now remember, we must count the number of times we need to move our decimal point. So let us count. 1, 2, 3, 4, 5, 6, 7. Next, we drop the non-significant digit and we multiply the new number by 10 to the power of n. Now, why do we have 10 to the power of 7? Or why is our n positive 7? Again, because we moved our decimal point 7 times and we moved our decimal point to the left. So as the rule said, when we move our decimal point to the left, the exponent would be positive. So that is why you have positive 7. So your final answer would be 4.015 times 10 to the power of 7. Okay, very easy. Another example number 4. The mass of a proton molecule is found to be around 0.000000001670621 gram. Write this measurement in the scientific notation. So you see, this is a bit difficult to record. So we need to use scientific notation recording this. So how do you write this in the scientific notation? Okay, first, you write the given, locate the decimal point. So you have your decimal point there. Then locate the first non-zero digit from the left, and beside it is where we are going to move our decimal point. Okay, ready? Okay, let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, next, drop the non-significant digits, multiply it by 10 to the power of n. Now, why do we have 10 to the power of negative 11? Or why is our n negative 11? Again, because we moved our decimal point 11 times, and we moved our decimal point to the right. So as the rule said, when we move our decimal point to the right, the exponent would be negative. So your final answer would be 1.67 1.6706 times 10 to the power of negative 11 grams. So do not forget to indicate the unit gram. Now what about if you are asked to do the reverse? Meaning, you are given the scientific notation and you are asked to write it back to its original form. Or sometimes we call it the decimal notation. Do you have any idea? Okay, you're right. So all we need to do is to simply follow the steps in the reverse order. Do you want an example? Okay, let us start. The speed of sound, according to the scientists, is 3 times 10 to the power of 8 meters per second. Write this measurement in the decimal notation or in the ordinary form. Okay, so solution, we write 3 times 10 to the power of 8. Now, since our exponent is 10 to the power of 8, so we will move our decimal point 8 times. Still 8 times, but this time, we're going to use the reverse rule. If it is positive, we need to move the decimal point to the right. Again, the reverse rule, if the exponent is positive, we need to move our decimal point to the right. So first, you locate the decimal point to the right of the whole number, and then we move the decimal point 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So we transfer our decimal point there. Now for every decimal place, you write zeros. Presto! You now have your number back into its original form or in the decimal notation. So your final answer would be 300 million meters per second. Now let us have now our last example. The length of a bacterium based on record was 4.5 times 10 to the power of negative 6 inch. What is its length in the decimal notation? So solution, we write 4.5 times 10 to the power of negative 6. Now, let us analyze. Since our exponent part is 10 to the power of negative 6, so we need to move our decimal point 6 times. And the reverse rule, if the exponent given is negative, so we need to move our decimal point to the left. So locate your decimal point, move it 6 times to the left. 1, 2, 3, 4, 5, and 6. So you move our decimal point here, and for each decimal place, we add 0. Presto! You now have your final answer, 0.000045 inch. Okay, so that's all for now, kids. So I know it's a bit confusing at first, but keep repeating the video and keep practicing. You can easily master this. So that's all for now. Goodbye, everyone.